Welcome to Impulse. Electromobility is picking up speed. In 2020, the rate of e-vehicles was still less than 5%. For 2023, the International Energy Agency expects 18% of all vehicles sold worldwide to be electrically powered. For the upswing to continue successfully, more and efficient production facilities for battery manufacturing will be needed in the future. Today, we look at research and show how automation can support this important aspect of the mobility transition. For the start, I now welcome Frank Fiedler in our studio. Hi, Frank.
Hello, Philip.
Frank, IFM is traditionally closely linked to the automotive industry. How does the company focus on the new topics, mainly the electromobility?
Yes, automotive industry is in the transmission of the market for sure, as we all know. So IFM has focused a while ago on that topics. We learned that inside the EV car production, the battery and the e-motor representing the main added value in a car.
Yeah.
So we were building up our expertise in that field. We did that together with external partners. Started with a technical university, the RWTH here in Aachen nearby. We did it together with the VDMA, that is a German machine building association. And we did it for sure with Fraunhofer Institute. Yeah, that was necessary for us to create all this know-how, but we also did it together with our global customers.
Yeah.
And together with our global sales team. We needed to have reliable application to use it as a reference. And for sure, just to give you an idea about the market, that is a huge market, and that is the reason why we are focusing. So every 6th new car is an EV car. So if you just go back to year 2021, there were 7.5 million new EV cars, and that was supported with, let's say, 8 plants and a capacity of 230 gigawatt hours, and an invest about 10 billion euros. And so the forecast for 2030 is to reach 5.6 terawatt hours. That is a huge increase. And the announcement is to have 200 battery plants in place with an invest of, let's say, 300 billion euros. That is a huge amount of invest and offers opportunities.
Yeah, huge opportunities, but also new applications, new challenges that have to be overcome. Together with IFM, hopefully. What solutions do you offer your customers regarding automation and even digitalization, to compete in this market?
Yeah. So IFM has started with the battery production. You could see here the battery pack that is under the button of an EV car. The battery pack is consisting out of modules that are the bigger parts inside. And each module is consisting out of battery cells. And that is a topic we are talking today about. So the battery cell production is starting with a quite chemical part, which have some special requirements. We will see some and hear something later on. So we are talking about mixing solution and coating solution, where we have some good solution prepared. And afterwards, you have a lot of robotics application inside, and for sure, our approach is not just to offer our single sensors, because the market is driven from Asia, right strong, and we have to offer something as an added value for the customers, which help them to be competitive. Also for us, it's important to get a feet into the door to be considered in the market.
You mentioned robotics, and you are the responsible for robotic industries at IFM. Do you see even there new applications, new opportunities, new solutions that are needed for the robotics industry to solve the challenges in the electromobility or in the battery production?
Yeah, for sure. But just if you compare, so even in the classical car, you have to build a car, you have to weld the body of a car, you have to paint the car, you have to assemble everything together.
Yeah.
And EV car production is partly different, but also there you have to weld the body of the car or to glue it together, depending on the material. You have to paint it for sure, and you have to assemble a lot of parts. Yeah. So that is for sure competitive, so that you have same processes. But if you just take out the battery production, for sure we have application, as I mentioned, for chemical parts, but also if you consider the robotics part, a lot of robotics application. So right from the beginning, where you have to stack all the foil sheets, for example, up to the process where the battery pack here is assembled together, you need to have a robotic application. Yeah.
You also mentioned the global approach, the global working together with sales teams and customers and yes, even universities. How's your approach for the next years to get into the market of electromobility? How is your team, or how are your teams set up or strengthened to find the right answers and get the opportunities?
Yeah, so we have built up a common team, a common structure, let's say. So we have an automotive team which is taking care for all the end user which are producing the cars. That is our view on the market, and all the supplier for a car manufacturer. They have to take care that IFM is listed in a specification. The specification allows to use parts or even not. Yeah. And all the OEMs have to apply this specification, and the robotics team is working together with the OEMs and helps them to find the right solution, and also help them to find the right products which are listed in the specification. Yeah. So it means we have to, or we attack the market from two directions, and that is something IFM could do and has do also in the past, because projects are globally, and we have to work globally with customers.
Yeah. Okay, so good luck with that in the future. Thanks. And until up from now. We will see us later in the show again. But now I will head over to Thomas Adamus, who's waiting for me in our machine hall, and talk with him about the first steps of battery cell production.
Okay.
Thank you, Frank.
Thank you.
See you.
See you.
So here we are at our IFM machine hall, where I will meet my colleague Thomas now to talk about this huge machine. Just let me find a way upstairs. Should be this ladder here. And here we are, and here's Thomas. Thomas, thank you for waiting.
Hello, Philip.
Thanks for having us. Thank you for being here. Yeah, this is an impressive plant. Can you tell us what exactly is done here? What kind of machine is this?
Yeah, we are standing here in the mixing plant, directly on a platform where you can see the supply tanks with the ingredients. And next to us is a big mixing machine. Here you have the mixing for the lithium-ion battery slurry. The mixing could be divided into two types. You have the batch method and the continuous method. Here we have the batch method. It's also very common in the food industry.
Okay.
And you can see here the big planetary mixing tool and the big mixing tank. And as you can see, all the motors, the mixing tool is driven by these motors and the gearbox. And the mixer dispenses the active materials and the solvent and also the conductive additives to a black sludge called slurry, which is used in the next production step at the slot nozzle to be coated on a carrier film.
Yeah, this is the second step,
yes.
The second part that we will move over later. But back to the mixing process. From a technical point of view, what is important to ensure the high quality production of the slurry which is needed then to produce high quality batteries?
Yeah, the mixing procedure is very complicated and very complex. Every battery cell manufacturer has its own ingredients, amount of ingredients and parameters, different recipes, and errors in this early stage of production are multiplied, it become very expensive in late stages. So we have the critical parameters like the temperature and the control of the pressure and the pressure monitoring. and also the mixing speed is important, and of course the correct function of the mixing tool.
Yeah, yeah. So why are these values or these parameters so important for the quality?
Yeah, at the end, these critical parameters affect one thing, the correct dispersion and distribution in the mixer. So, because when an error occurs at an early stage, it is noticeable at the coating, when the slurry cannot be applied properly, or when after the drying the error comes visible. You have blank spaces. But in the worst case, such an error is noticeable at the late stage. For example, the grading, one of the latest processes. So the battery is graded and the values are bad or incorrect. And you can imagine there are many production steps before a battery cell is finished, and it's a lot of energy and cost which are generated.
Yeah, and waste is produced.
Yes, waste also. But some of the errors, according to the mixing tool, can be avoided. For example, the mixing speed, if it's insufficient, not correct, or a defect motor can be avoided with the correct hardware and software.
Yeah, it's important, I guess, if you minimize the errors directly the first step, so then you can minimize the waste and wasted material and wasted money in the further production step. So you mentioned the condition monitoring or the monitoring of the motors. IFM has a big expertise in vibration analysis, and we can also see here every motor is equipped with several sensors, and you can see the infrastructure, cables and I-Link masters. What kind of solution does IFM offer for this mixing process?
Yeah. You mentioned our solution. You can see the motors here with our vibration sensors, but the critical part is the mixing, as I mentioned, and we offer a solution for our customer. It's already used by manufacturers of mixing equipment. Our solution includes the software and the hardware to detect and analyze critical parameters for the machine house. We record, as mentioned, the vibration of the motor, the temperature, and the speed of the motor to give a statement about the condition, and to predictive. So we are working here proactive. That means our customer is able to plan maintenance and avoid downtimes. So we are talking about reducing the material costs and maintenance costs by up to 50 to 60%, and also the downtime up to 60%. So it's a huge advantage in machine availability.
Yeah, it's a huge amount of savings.
Yes.
When I was climbing up this ladder, I saw another sensor of IFM, the MVQ, the smart valve sensor. I would guess that has something to do with bringing the right amount of ingredients to the mixing process. So this is another aspect of quality saving in this process.
Yeah, that's right. There we are talking more about the quality, but I mentioned the errors which can occur at this early stage of production. This also refers to the right mixing ratio of ingredients, the active materials, the solvent, and the conductive additives. So our MVQ can help there because it can detect in an early stage if the function of the valve is rejected or not correct. And that means it can detect the slightest blockades or a wear on the valve seam. So we have the condition-based monitoring of the valve. And this also leads an increase of the quality, but also reducing the downtimes and rejects and costs.
Yeah. Okay. So all in all, the monitoring of the motors and temperature and pressure, of course, also, and the MVQs down there on the pipes, it seems to me like this is the perfect all-in-one solution that IFM offers to these customers of the mixing process.
There are two parts. If you see this plant, we have a lot of more sensors and hardware here implemented, but from our point of view, it's a best use for our customer best choice to where he can benefit the most from. So the machine availability from the motor part and the quality from the MVQ.
Yeah, so it's the perfect start to get the most savings, and then you can add other cylinders to get up
the extra.
The extra, okay, perfect.
Yeah.
So Thomas, thank you for being here with us once again. Thank you for sharing your expertise with us.
Thank you for having me, Philip.
And we will now head over to the second step of the battery production. Thomas already mentioned it. It's the coating process. And yes, we will see us at the coating plant. Good to be back on the ground again. So now let's have a closer look at the second step of the process, the coating. We visited our partner from Fraunhofer FFB to give you a deeper insight how automation solutions can help to improve this process. But see for yourself.
Wir befinden uns hier gerade in Münster im FFB Workspace. Das ist der Standort der Fraunhofer FFB, an dem wir die ersten Prozessschritte der Batteriezellfertigung bereits operativ abbilden können. Das wären zum einen das Dosieren und Mischen und zum anderen das Beschichten und Trocknen. Beim Dosieren und Mischen kommt hier ein Extruder zum Einsatz, bei dem die Elektrodenpaste kontinuierlich hergestellt wird. Im zweiten Prozessschritt, dem Beschichten und Trocknen, wird dann der Slurry auf Substratfolien appliziert. Nach dem Trocknungsprozess wird die Bahn dann über mehrere Kühlwalzen umgelenkt, um eben das Produkt abzukühlen und anschließend aufgewickelt. Das Zielbild der Fraunhofer FFB ist es, die Großserienproduktion zu ermöglichen mit der technischen Infrastruktur, um eben Batteriezellen in sehr hohen Durchsätzen produzieren zu können. Und gerade hier in Europa ist es extrem wichtig, um eben wettbewerbsfähig zu sein, dass die Batteriezellhersteller noch deutlich effizienter werden, als es derzeit der Fall ist. Ein Ansatz, um das eben zu ermöglichen, ist der Einsatz von Sensorik und Messtechnik. Im Rahmen des gemeinsamen Projektes mit IFM setzen wir Objekterkennungssensoren der O2D-Serie ein. Die erste Anwendung ist die Inspektion des Nassfilms. Hierbei wird die Oberfläche auf diverse Defekte wie beispielsweise Kontamination, Agglomerate, Luftblasen oder ausgelassene Bereiche untersucht. Diese Defekte können dann später in der Batteriezelle sowohl sicherheits- als auch performancekritisch sein und müssen daher zwingend als Ausschuss identifiziert werden. Im zweiten Anwendungsfall betrachten wir ebenfalls den Nassfilm. Hierbei prüfen wir die Dimensionierung der Beschichtung. Dann betrachten wir noch bei der doppelseitigen Beschichtung den Versatz von A zu B-Seite. Im dritten Anwendungsfall befinden wir uns hinten nach dem Trockner. Da wird die Bahn- und Beschichtungskante erfasst. Das ist insofern wichtig, als dass beim Aufrollen diese genau deckungsgleich übereinander liegen müssen, um eben den Transport in den nächsten Prozessschritt zu realisieren, sowie dass die Beschichtung genau aufeinander liegt, damit es nicht zu Spannung auf der Oberfläche kommt. Durch die Daten, die wirklich entlang der gesamten Prozesskette erfasst werden, können Ursache-Wirkungszusammenhänge zwischen Produkt und Prozess identifiziert werden, aber auch die Daten dafür genutzt werden, einen digitalen Produktzwilling zu erzeugen. Das gemeinsame Projekt ist ein gutes Beispiel dafür, dass Kooperationspartner auf uns zukommen können, um mit uns gemeinsam die Technologie in der Batteriezellproduktion zu erproben und dann auch gemeinsam gegebenenfalls hoch zu skalieren.
Finally, let's talk about the current situation and the future of battery production in Europe. And therefore, I'm pleased to welcome Dr. Thomas Pausen from the Fraunhofer FFB. Welcome.
Hello.
And once again, back in the studio is Frank Fiedler. Welcome back, Frank.
Hello, Philip.
So, Dr. Pausen, as Fabian Cooks already mentioned, the European battery production needs to be or needs to get more efficient. From your point of view, how would you assess the current European competitiveness compared to the global market?
Yeah, I would like to divide this question into, let's say, at least two parts. First of all, we have the cell manufacturers, and when we look at this industry, we can observe that the major production capacities with the up and running gigafactories are mainly today in Asia, and therefore they're especially in China. In the last 2 to 3 years, there were major announcements from cell manufacturers to set up production facilities in Europe and within Europe, especially in Germany. So Germany was or is one hotspot for cell production. Besides other countries in Europe, but we can see some hotspots.
Yeah.
One of them is Germany. But what I also have to name is that there were currently some political influences, like the Inflation Reduction Act or matching initiatives from other countries to match these funding opportunities in their specific countries. And this might shake up the market a little bit. So we observe we think that some manufacturers will overthink their investment decisions or their site decisions where to set up gigafactories, and there are certainly things going on. When we come to the equipment industry, so the second perspective, there the market is also strongly dominated currently by Asian suppliers. Probably everybody knows companies like Wuxi Lead, which are able to offer turnkey solutions for cell manufacturing, also for module and pack manufacturing. But there are certain spots in the production value chain where European or German companies can bring in added value, and not specific on, let's say, big machine level, but on certain machine module level, for example. And another important or interesting aspect is that we see that the European companies are currently fostering strategic alliances with other European companies to be able to offer turnkey solutions to their customer. So all in all, I would assess the European competitiveness as good, as strong, but let's say in an attacking position compared to the Asian players.
Yeah, okay. The European Battery Alliance, which is industry-led, predicts that by 2030, so in 7 years, enough batteries will be produced to supply about 11 million electric cars, which they say would moving them very quickly towards strategic autonomy in this crucial sector. Is this then a realistic scenario that after 7 years or some years later, Europe and Germany will be a big player in this market?
I think it's possible that we can reach this, let's say, strategic autonomy, but probably these numbers also reflect the cell manufacturing capacity. What also have to keep in mind is that we also source currently all the active material, all the ingredients for a battery, basically in Asia and also especially in China. So when we talk about strategic autonomy, it's not only important to set up cell manufacturing sites, it's also necessary to have the European value chain in place. That means starting from active material production, precursors for active material, cell production, module and pack production, but also when it comes to recycling and other REX approaches to somehow close the material loop and having a full value circle in Europe.
Yeah, so there's a lot of work to do.
There is a lot of work to do, but there are also quite a lot of things going on in Europe in these single spots of the value chain.
Yeah, okay, perfect. So we also heard in the video already that the goal of the Fraunhofer FFB is to enable large-scale production. Why don't you leave this development part to the entirely to the commercial market players? Why do you support them in this way?
So we as Fraunhofer FFB offer a research and development environment where partners bring in their innovations or can bring in their innovations, and we support them in scaling up, so in further development of their innovations. By innovations, we mean basically two things: everything which is somehow new on the level of a single battery cell, new materials, new separators, new copper foils for current collectors or what else. And on the other hand, new production processes, new innovation when it comes to production, starting from big machines, single tools, slot dies or whatever, or even sensors and other quality inspection systems. And what we observe is that the production process of battery cells consists of 15 to 20 single process steps, starting from serial production up to formation and aging. And the companies are quite good or very, very good in their own production process. So they know exactly what to do in their own production process. But then there are 18, 19 other process steps where completely different expertise and knowledge is asked for. And basically what we do, we bring all the knowledge the company has not to set up a development project and being able to scale up innovations. And especially in battery cell manufacturing, it's important at a certain point to build battery cells with your innovation, for example, with your new active material, and that asks for having a full value chain for battery cells, being able to build battery cells. Also in the area of the equipment, when you think, for example, on a company which produces and sells extrusion lines. These extrusion lines can be used for serial production. But taking such an extrusion lines, putting material in and making some trials is the one thing. The other thing is getting access to the right active materials. having knowledge about the electrochemistry behind these active materials, being able to produce a good slurry, having the opportunity and the knowledge to evaluate the slurry, and making battery cells out of this slurry which was produced by the new innovation or by the new machine. That's exactly the point where we come into the game and where we can support partners and companies with this, let's say, knowledge infrastructure processes the single company does not have in place on their own.
Yeah. So you're gathering all the expertise that is needed for the whole process.
Exactly.
At one point. Okay,
exactly.
Perfect. Of course, the automotive industry is the biggest player or the biggest partner, maybe also in the battery production. Do you have other industries in mind that could participate in this development?
So when it comes to the application of the battery cells, of course, in Europe or in Germany, the automotive industry is one of the biggest, but we have no, let's say, boundaries for application of battery cells. We try to somehow serve all application areas for batteries, for example, electrical flying, but also home storages and, of course, automotive. But another big area for us is the equipment industry, of course, because we do research on the production processes. We try to make battery cell production more efficient and sustainable, and therefore we are in close contact with basically all the equipment manufacturers who provide and sell equipment for cell production.
And also with IFM as an automation partner. How important is this broad approach, not only to partner with OEMs or production industry, but also with all these suppliers and automation partners?
Yeah. It's really, really important for us, and it absolutely adds value to the whole story, because new ideas can basically arise from multiple sources. Two of them are, of course, academia, and the other one is, of course, industrial research. And there are so many good R&D engineers out there, and having an exchange with these R&D engineers, somehow doing some kind of co-creation, getting access to the ideas, the R&D engineers from the academia and academia from the R&D engineers, allows to make even better innovations, to make even better, having better ideas, and to strengthen basically the European value chain.
Okay, thank you. Frank, now to you. As an automation specialist, IFM is strongly networked in the automotive and robotics industry. From your point of view, how could these industries benefit from your cooperation with the FFB?
Yes, a big advantage and a big opportunity for us is to work close with FFB, because we could test our products under realistic conditions. That is necessary for us, and it's important because you could learn about the processes and the needs behind, and it is not that easy to do that with a production line. So they have to stop, and you have to fit in your products. That is the first hurdle, and the next one is all these companies. That is a sensitive market. They try to keep their knowledge in their hand and do not want to give too much outside. So that is the situation. So that is possible with Fraunhofer FFB. So on basis of this, we could work on solution, solve application, and try to create a good customer use case. Yeah. Next good opportunity is that we could work in a cooperation with a third party. So machine builder, for example, on a realistic condition with the production in FFB, and together with our products. So that is a benefit for both sides, for the machine builder for sure, and also for FFB, yeah, to test their equipment and to work on good solution, and also for IFM. We could adapt our products also in regards of this application, and that is at the end a benefit for the OEMs you mentioned.
Yeah.
What is also important from my point of view, that we could work and learn together with FFB about the ramp up. So FFB is ramp up the production step by step, and machinery is also getting bigger, and the capacity is getting bigger. And that enables also IFM to learn if our products are fitting to a bigger machinery and let's say also faster working machinery, and at the end it's a benefit also for the OEMs, for the machine builders. So that is at the end a part which you could use in both directions. Yeah. If you could take all this, that helps us all to win more market shares, to balance the market a little bit against the strong Asian market. That is something we should also keep in our mind, and that is also one of the message I've recognized also from FFB, that we could support and chance to work under realistic condition.
Yeah. Yeah. So all that you've described is how the OEMs benefit from the cooperation between IFM and FFB and the supplies. But is it also the other way around? Can you use the knowledge that you have in partnering with the OEMs to bring this in, vice versa, into the cooperation with the FFB?
Yes. So IFM has a long-term knowledge about assembly automation, which is in robotics industry. We have a long history in automotive industry, which is one of our main market within IFM, and both are working on good solution and application. So we have a wide range of products which are fitting to the production of battery production for sure, and that is starting from, let's say, from simple position sensors, process sensors we have in our range, and up to IO-Link solution, up to software solution in combination like Moneo, which enable customers to create a digitalization strategy up to the cloud, and that is something we could also bring in the cooperation, and and helps all parties to enable their knowledge in that regards. We have a lot of standard products in our portfolio. That is also a benefit if you think about that customers have to enlarge their production line step by step, so they have to ramp up, quite similar to a Fraunhofer FFB, due to the capacity they have to produce. And if you have standard products, in best case with a good solution like IO-Link, to have an easy connection with all the sensors and to bring that in their concept, that helps you to have a kind of standard in your machinery for the whole process line. It enables customers to set up their own, let's say, strategy in regards of digitalization. And the next thing we could bring also with us is that we also have solutions which are not direct in the process, in the production process. That is more environmental. So if you just take care and keep in your mind that we have energy concepts to take care, that compressed air is used, that you have no losses, that you could save costs, because battery production is a very cost-intensive production, and for sure they have to take care for their costs. And also machine health is a topic to take care about. Oil condition, clean room condition is also something we could have in our mind. So that is a big package we could bring with us. Yeah.
And also maybe not to forget the intralogistics solutions.
For sure. Yeah.
Mr. Pausen, we heard, and Frank said it, these internal developments at the OEMs are their best kept secrets. So we all won't get insights to that. So this described cooperation, this transfer of knowledge between all these parties that are cooperating with you, with the FFB. How important is this knowledge transfer between all these parties to then strengthen Europe as an important battery player?
Yeah. It's extremely important for us, for the whole value chain basically. And what we see is that compared to other industries, the battery industry, the battery cell industry is extremely close. So there's nobody out there who would like to share information about efficiency, energy consumption, scrap rates, or what else regarding the production process. So basically, because it's currently Asian dominated, but there's a very, very limited willingness to share information and to get information. So basically crafting own information and crafting own knowledge is the only way out of this challenge. And with collaborations between companies and academia, it's one good way to craft faster knowledge instead of making everything on their own.
Yeah, and then so maybe FFB brings a bit more transparency to all this battery production. This could also be helpful then for others, of course, that maybe don't share their knowledge, but all in all, it's beneficial for the European development.
Exactly, because we are trying to do it the other way around. We are an, let's say, open battery cell manufacturing plant, which are able and willing to share information about current state of production or future production by projects, by publications, by white papers, by interviews, by basically everything we do.
Perfect. So compared maybe to the whole development of battery or electromobility, FFB, the Fraunhofer FFB is quite at the start of their development. What are the upcoming steps? What are the long-term goals?
Yeah, our organization, so the Fraunhofer FFB as part of the Fraunhofer Gesellschaft exists for 3.5 years. I'm with Fraunhofer FFB since 3 years. Usually the growth is starting very slow. The first employee has the second one and so on and so on. Currently we are more than 100 full-time equivalents in Münster. And since 2021, which was our first milestone, we are operating the FFB workspace, where also the videos with Fabian Cooks were taken. And since the beginning of 2023, we are having the prefab, FFB prefab, where the construction of the building is already finished, and we are currently inserting dry and clean rooms inside the building, so the building interior. And the first machine will arrive in the fall. We have to bring them in, scale them up, ramp them up, and so on and so forth. So we expect start of operations in the summer next year, so which will be the, let's say, second big milestone. And in parallel, we are setting up the so-called FFB Fab, which is the gigafactory, which will be in the neighborhood of the prefab. When we look at the prefab, we have a production capacity of 200 megawatt hours per year, and the fab, in the gigafab, we will have 6.8 gigawatt hours annual production capacity. So it's a real gigafactory. And we are currently in a late planning phase for the fab, for the big one, and we expect start of construction next year for the big one.
Okay, perfect. So then the opportunities to join in research projects are growing more and more.
Exactly.
Yeah, perfect. Frank, from IFM's point of view, how will you continue to accompany the topic of battery production as part of automobility and also maybe from a point of view of robotics?
Yeah. So for sure we have a red line for taking care of all of this, let's say, topics. So battery cell production was a starting point. So we also worked on the production of battery modules and battery packs for sure. And our next steps are the following processes to close the circle, like you said. So we also focusing on battery recycling, which is one of the main topics. So we all have this material here in place in Europe and do not have to dig it out somewhere else on the world. So that is something we definitely follow. Next topic is to think about different battery cell concepts. So some new concepts are existing. The process steps are partly different to the battery cell we today talk about. So we have to adapt our application and our products for sure. And for that reason, we need to focus on that. We also take care for, let's say, charging and infrastructure concepts. So, for example, in Asia we have a swap station, which are interesting, but we have to take care where in the world are they fit into the concepts. But at the end, IFM is globally, and we have to follow the market globally, and that is a topic for automotive and robotics, which are our focus industry, which take care about that. And last but not least, fuel cell technology is a quite new technology. It's not that big like battery concepts, but that is something also for the future we should take in our mind.
Yeah. So it won't get boring for you as well.
No, I think no.
Okay, perfect.
Yeah.
So yeah, I hope and I think there's a lot of topics to talk about. Maybe in some further months when the next milestones were taken. Thank you, Mr. Pausen, for being here today. Thank you for sharing your experience with us. Thank you, Frank, for being here.
Thank you.
And this is the end of this episode of Impulse. Thanks for joining us today. Hope you enjoyed it as I did. And hope you will join us next time again. Until then, take care, see you, and bye.